Okay, this is chapter 21. This is actually number 19. That's a typo there. Pause the video and read this paragraph. Make sure you understand the setup. Okay, hopefully you've done that. This is a two-proportion confidence interval. We have two groups, and we're going to compare the success rate from one group versus the other. First thing we want to do is identify what our population and our success are. So if we read this, our population is babies, and the successful ones got ear infections. Notice we have two groups. We've got unvaccinated and vaccinated, but those are just the two groups that make up the population. So the first thing we have to do is write out our variable, identify our variable. Let P be the proportion of babies that got ear infections. Then we split up our two groups. Each group comes with their own sample statistics. Group 1 turns out to be the unvaccinated kids because they have the higher sample success rate. 20% of unvaccinated kids got ear infections versus 13.6% of the vaccinated kids. Remember, always choose group 1 to be the one with the higher p-hat. Then we pull out our fancy calculator. Calculator does all the work for us. So we'll go stat, over to tests, and we want to go to B. And we're just going to type in all 6 of our numbers, the X's and the N's. So 499 out of 2452. It is important you get the ones and the ones. 333, 2455. And we hit enter. We're doing a 95% confidence interval. Hit calculate, and we're done. There are our numbers. So about 4.7% and 8.9%. And then here's the hard part, writing out the interval. Remember, we're always measuring how much higher group 1 is than group 2. So our sentence is we're 95% confident the success rate for 1 is between this and this, higher than the success rate for 2. So we're 95% confident the proportion of unvaccinated babies that get ear infections is between 4.7 and 8.9% higher than the proportion for vaccinated babies. Okay, the follow-up question is, does that make it seem like the vaccine is effective? Well, yeah, it's effective. It lowered the ear infection rate. It wasn't perfectly effective. It didn't lower it to 0, but it looks like it's approximately about a 7.7% difference, plus or minus some. Remember, this interval is always the observed difference, which is about 6.5%, plus or minus the margin of error. So our margin of error, just for fun, let's find that. That's always high minus low divided by 2. So if we do that, we get a margin of error about 2%. So the observed difference was about 6.5 plus about 2% would get me up to 8.9 and down to 4.5.